Good morning, everyone, and welcome to today's webinar, Then and Now In-House PCB Prototyping Since the 90s. We are live from LPKF Studios in Tualatin, Oregon, and are excited to share a little bit of LPKF history with everyone today. This webinar is a great opportunity to discover how in-house PCB prototyping has changed in the past 20 years and what features are now available. My name is Ashley, and I am the Marketing Coordinator here at LPKF, and I am joined today by my colleagues Shane Stafford and Rory Grondin, who will be your guides to the past 20 years of LPKF in-house PCB prototyping. If you have any questions during the webinar, you can submit them via GoTo's questions form as seen on the screen, or you can submit them via Twitter by tweeting #LPKF or at @LPKF_USA. At the end of the webinar, we will take time to answer any questions you may have. At this time, I would like to pass the microphone over to Shane and Rory, so buckle your seatbelts and get ready for a blast to the past.
Thanks, Ashley. And thanks, everyone, for stopping in today. Today, we're going to cover a few things. So we're going to take a look and see how in-house prototyping has really advanced over the past 20 years and how that's followed a trend nationally of technology advancement trends. So we're going to cover how machines have improved. This is going to include new machine features and overall improvements. We're going to cover the applications of those improvements. What are they really benefiting? And then at the end, we're going to bring it all together. What are the overriding implications for the new features and the new technologies we've advanced? But to get this trip started, let's go ahead and jump on our DeLorean, get on our Marty McFly shoes, and head back to a little place I like to call 1994. Now, in 1994, this was the first year LPKF introduced a streamlined line of CNC PCB milling machines. These were the 91S, the 92S, and the 93S. Now, back these days, when you were deciding which protomat to purchase, your purchase was based largely on spindle speed and working area size. At this time, a lot of the advanced substrates, Teflon and Rogers, were not in wide use. So the need for a lot of advanced features was not there. But in the mid-90s, we saw a breakthrough of technology in this country, which really propelled us to where we are today. So let's get our DeLorean, jump a year ahead to 1995. You remember 1995 technology. You had cell phones where the antenna was just about as big as cell phones are today. At home or at work, you're likely on Windows 95, which I remember well. And then your Mac, well, if you had a Mac, as you can see on the screen, it was pretty dated. So along with this, in 1995, LPKF said, hey, let's start introducing some new features. So in 1995, LPKF introduced the Protomat 95S. And with the Protomat 95S was the automatic tool change. Now, I'm going to bring in Rory here. Rory Grondin is the Senior Sales Associate of Protomats here. Rory, talk to us a little bit about the introduction of the automatic tool change with the Protomat 95S and a little bit about how it's progressed.
So with the automatic tool change feature, it was actually introduced on one of the higher end systems, the 95S, because those machines were going into facilities and companies that wanted to minimize the amount of hands-on time that the engineer would have to dedicate to the machine in order to create their boards. And we were able to fit a 30-position tool change into this 95S system. And again, it was one of the very high-end machines. So the advances over the years, we've been able to incorporate that same tool change design, that same feature in even our middle-of-the-line products, and actually as an upgradable feature for our entry level. And the big benefit of that is that a project may only take 6 to 8 tools, and 30 positions was redundant. You'd have plenty of backup tools. And with the new systems, you actually have 15-position tool change, which covers more than enough for a standard prototype, even with very tight traces for surface milling, drilling, and cutting.
So even though the Protomat 95S was introduced with 30 positions, and today's Protomat S63 and S103 have 15 positions, it's not really a downgrade, right?
No, it's more the ability to incorporate a feature at the same price point or almost the same price point as the machines were before, but for a wider range of customers, ones that really don't need the advanced high-end units with faster spindle speeds and large work area, So we're able to cover a wider range of customers and offer that to benefit with their projects and their time savings.
That's awesome. And having worked in our lab here in Tualatin, I can say it's just great being able to leave the machine while it's working and go work on something else in the meantime. I love it. So, also introduced in 1995 with the Protomat 95S was the pneumatic non-contact depth limiter, or as we casually call it around here, the airfoot. Rory, why don't you talk a little bit about the airfoot and what applications it benefits?
Yeah, so the airfoot was introduced with the 95S, and it actually prevents contact from the machine itself, the foot that would normally ride the surface and lift and lower with any variations in material height or warp in the material. And it actually eliminates that contact so that only the tool is touching the material itself. So this feature, again, only included on the advanced machines in the past, but incorporated down into some of the more common and standard machines to cover more applications. So that airfoot, compressed air is actually forced from underneath the foot, maintains the surface height and the depth of the cut with the tool, but also prevents any micro scratches that might occur with RF materials, Rogers, or gold-plated substrates that you want to really minimize the effect on that material.
Yeah, I mean that's perfect. I was going to mention the gold substrates, and it really helps out with those. So, but let's jump back in our DeLorean and move ahead a little bit to 99. Now, you may remember in 99, cell phones now could actually easily fit into one hand. You were likely operating on Windows 98 at home or in the office. And you may remember from 99 the crazy matte color phase that was going. And while, yes, it still seems a little dated, it was this trend that things were becoming a little more into their modern shape. And one thing that we introduced in 1999 was the extra-large working area. Now, the Protomat M60 is the system this was introduced on. And now, today, you actually have the Protomat X60, which has even a larger working table. But Rory, I wanted to ask you about this. Is the large working area, is this simply a case of bigger being better?
Well, it comes down to applications. And at the time, there was the need for large antennas, large controller boards, the need for panelizing, and depaneling maybe a panel of populated boards. So that's where the jump from the M60 and X60 really had its advantages for our customer base. And LPKF really designs their products with customer feedback and matches what the industry would benefit from. So having the large work area isn't just based on, bigger is better, but it was intended for the applications at the time. And we actually still do have the X60 model available because there is the occasional need for larger boards to be created, antennas, controller boards, but the standard has been going to the smaller machines because everything in the electronics has been reduced in size with advances over the years.
So it really shows how we've kind of been able to listen to customer feedback and follow the trends of the applications going on and be able to adjust our machines with that. It's really cool. So I don't know, that was our big thing from 1999 beyond the Y2K fake disaster. Also in 2003, if we move a little bit ahead, now here's where you can see technology really beginning to look a little more advanced. You can see on the left, this was the first cell phone that actually had a color video screen. By now, you're likely operating on, if you're at work, at Windows 2000, if at home, maybe on Windows Millennium Edition. And you can see the iMac on the right really begin to take its modern shape. 2003 is really a turning point for technology in terms of this turning point. And speaking of turning points, in 2003, we introduced a couple of really great features. The first of which is the Fiducial recognition camera. And this was introduced with the Protomat H100, which is one of our high-end machines. And the Fiducial recognition camera actually fully automates board alignment. Now, Rory, me and you have actually talked a lot about the Fiducial recognition camera before. And so why don't you just talk a little about how the Fiducial recognition camera works and how it's available now, not just on the high-end H100, but also some of the more standard machines.
Yeah, the Fiducial recognition camera really saved a lot of time with the applications and made the projects even more precise. It actually is used to register 3 or 4 Fiducial locations or drill holes, and the machine will actually drill those at the beginning of the project. So with the Fiducial recognition, the camera will actually register the location of the board, based on the original fiducials that you drill. It will also even recognize drill holes should you depanel from those original fiducials that you drill, so that you can reload a board and do some rework or trimming. So here you see in the video, it actually drilled the 4 fiducial holes first. And now you see that it just registered the location, and it'll give you a second image with the fiducial screenshot in the software, registering the location of the contrast between light and dark. And that's really what the camera's looking for, is a specific size hole or actual copper pad. It will recognize either light to dark or dark to light. And this feature really did eliminate a lot of user time and inaccuracies that can occur with prototyping. Specifically, like we've talked about before, the set pins. Set pins were the standard. That's how you flipped and aligned your board from front to back. Now, if you've finished that board and you wanted to rework it, you would have no way to register it. Basically, you start over and redesign your layout. Now you can use the fiducial camera, register drill holes that are in the design, and assign those as fiducials, and then the camera does its registration and aligns it schematically in the software, it skews it to the true position XY that it registered with the camera.
I mean, and for those who go way back with in-house PCB prototyping, this is a huge thing, getting rid of the need for those set pins, being able to have the camera fully automate everything. It's really a huge bonus. So one of the best features that I think we've introduced. Wouldn't you say, Rory?
Absolutely, yeah.
Yeah. Also introduced in 2003 with the H100 was the vacuum table. Now, the vacuum table originally had sort of a honeycomb shape, and now it's actually changed to be a little more fluid than that. So, Rory, talk a little bit about what the vacuum table benefits and how it's changed.
Sure. So, again, going back, the features included with the high-end machines, the H100, was the vacuum table. The honeycomb material was really just that, a very basic material that allowed the air to flow through underneath your board, pull it flat, and take out any warps in the substrate. So it was securing the project, but also helping the material to be flat so that the foot could lift and lower with any variations and minimize those variations. So that material was replaced by a porous insert. So basically LPKF was able to adapt a porous insert material that would look more like a white cutting board you'd find in your kitchen. But with microporous holes in this, it still allows the airflow to pull through, but gives you an even more solid work surface that you're going to drill into, cut into, and eventually make look like Swiss cheese before you're going to replace that insert. And it is actually a low-cost replacement. A 4-pack on the standard machines is $150, so it's just a very simple consumable, and you can use both sides of it.
Yeah, I mean, I think it's really great that it's now a replaceable element, so you don't have to worry about replacing the whole vacuum feature.
Exactly.
So we're going to jump ahead a little bit further now. In 2005, the trend you saw was now technology was advancing, but now it was getting into all one compact package. So yeah, you could see the update in the operating system, Windows XP, which I had about 3 years too long on my computer. And then you can see the iMac really beginning to resemble its modern form. But on the left, we have the BlackBerry, which really was able to incorporate the best of telecommunications and the best of business computing all into one device, bringing everything into one package. And talking about bringing everything into one package, in 2005, with the first generation Protomat S series, we're able to introduce as a standard feature the acoustic cabinet. Now, the acoustic cabinet is good in that it reduces the amount of noise emitting from the machine, and it also provides safety. The other great thing about the standard acoustic cabinet in 2005 was, as you can see on the left, in the past we had offered an acoustic cabinet, but it was big, it looked somewhat like the refrigerator out on your back deck, and it was just clunky. In 2005, we were able to bring everything into one package so you could keep your acoustic cabinet with your milling machine on your benchtop. And now you can see how we've been able to sleek up the design a little bit. Kind of had a little fun analogy here. No offense to anyone who owns a Volkswagen Rabbit out there, but we were able to make it look a little bit cooler, which is just, I mean, it's just nice to have something that looks a little bit cooler in your office. But getting back to the functionality, I know that, Rory, I think universities and small businesses really enjoyed the acoustic cabinet feature. Why?
Yeah, so the acoustic cabinet, again, reserved for the high-end systems, or made available, but a higher cost option for some of the machines back when the older units were available. But the functionality reduced the noise of these machines. They were high-pitch, a little bit loud, going back into the 90s. And engineering actually has taken out that high-pitched noise, and now the machines, really the loudest part is the air flowing through the vacuum tube. So the acoustic cabinet helped reduce that noise even further, and so you can talk just as you and I are right next to the machine, even with the S series, the S62, S100 back in the mid-2000s. Now it's just an improved look and improved viewing section so that you can see your project even more visibly. So the sleek design actually has some functionality too. But again, incorporating something that was available on high-end machines and making it available for the lower end, it's a nice feature that comes standard with the S63, S103, and S43.
Yeah, and I think all of these trends, as we're going through them, it really reflects LPKF's desire to invest back in its systems. Talk a little bit about investing back in its systems.
Yeah, we actually take 20% of the company profits and reinvest it in research and development. So that goes directly into what we're able to include into our machines at the same price points as before, and basically engineer a way to include the tool change, which wouldn't have fit in the machines before. There was just no room, or the gantry was not able to get to where a tool change would need to be. Now those features, the camera, the vacuum table, the tool change, are included because we have invested the money to find a way to offer it at a low price, but also on machines that cover the whole range of applications.
Exactly, and segueing into our most modern systems, not only were we able to introduce new features with the new Protomat and S-Series, but we're able to, like you said, keep it at the lower price point of the earlier machines, or even lower than the earlier high-end machines, which is really cool. So as you can see up on the screen, now that our DeLorean has passed a little bit further into the future, now we're on Windows 7. I think some people are on Windows 8, but that's had some hiccups so far. You see the Samsung Galaxy on the left, which is another thing of just putting everything all into one device. And then the trend of like everything being even more compact on the right with the iPad, you see more and more businesses are actually using iPads for work reasons, which I think is personally really cool. Now, as far as features introduced with the second generation S-Series in 2011, one of these was the automatic tool depth calibration. Rory, the automatic tool depth calibration, it works with some of the other features that were introduced in the past. Talk a little bit about all it does.
Yeah, so with us investing in R&D and adding more features to the machines, even the middle of the line and entry level and upgradable features, there's an auto tool depth calibration that actually incorporates the Fiducial camera, but it actually will pick up a tool and set it to a point on a calibrated ramp to set the depth of cut for the operator. So this really reduces time and actually even lends to unattended operation once you tell it what the copper weight is that you're going to work with and tell the machine to start picking up tools and beginning the project. So this ramp is actually calibrated between 0 and 1.8 millimeter. And based on the copper width, it will set it to a point on that ramp that corresponds with half ounce or 1 ounce copper, so 18 micron or 35 micron. And then once it's set that depth, it will go and begin operations.
Yeah, and one of the great things, talking about incorporating with the other features, is it really works with the Fiducial camera on the scratch test. Talk a little bit about what we like to call the scratch test.
Exactly. The scratch test, if you've used one of these old machines before, you know that there's V-shaped tools and there's the need to dial in the cut width, because those tools will either cut between 4 and 8 mils wide or 8 and 12. And if your isolation calls for an 8 mil width, you need to dial that tool in. So the scratch test, it will actually now pick up that tool, touch it to a point on the ramp, and then go do a scratch test on its own, and then ask the operator if the test is the right diameter. But not only that, but the Fiducial camera actually reads the scratch test itself and does a measurement to verify the width itself. So the camera will do this automated, and then if it's not the right width, it will give an offset adjustment and then set the tool back to the ramp and dial in the correct depth for the operator.
I think that's really remarkable. Another thing introduced in 2011 with the Protomat S63 and S103, and again, going back to incorporating some of these more high-end features into the basic level systems, is the solder paste dispensing. Now, in a way, this actually eliminates the need for stencils when prototyping, which I think is really cool. Roy, talk about how the soldered paste dispensing works.
Yeah, down to a specific size for pads. You can actually dispense as small as 0.3 millimeter dots, so 12 mil, on 0.4 millimeter pads. So the solder paste dispensing is actually going off the SMT data, and it's going to dispense dot size that correlate with the pad size. And this is actually a feature that's included on the S63 and S103. All you need to do is connect compressed air and then the solder paste syringe. And we carry the solder paste syringe, or you can load a similar solder paste. But there's a heating element that's included, and it brings the paste to a viscosity that dispenses it very nicely on the pads and allows you to eliminate that stencil, as you said.
It's really cool to be able to incorporate all that into one package, I think. Another feature introduced in 2011 was CircuitPro software. Now, CircuitPro software really put things all together. Previously, on our Protomats, as some of you watching may know, we had two softwares, CircuitCam and Boardmaster. Now, CircuitCam, as you may have guessed, is the CAM software, and Boardmaster was the machining software. Now, CircuitPro actually combines the two. In addition to combining the two, it actually has some new features that make it an overall better piece of software. Rory, talk a little bit about CircuitPro.
Yeah, so CircuitPro basically is a combination of the two, where you'd have the ability to import your design data, Gerber, DXF, HPGL, ODB++, and in the CircuitPro side, there's the CAM view. And the CAM view allows you to import those files, preview them, make sure that they're being assigned to the right layer. And then after it's been previewed and imported, the software automatically calculates where to run the tools based on what tools you've actually purchased through LPKF. So it keeps track of that now, and it will only isolate with tools that you have available or make recommendations as such. After it's done its calculation of the tool path and insulated the design, it automatically opens up in the machining view, which is a second tab, and then you go straight into operating the machine. So that's one of the greatest things with the combination of these two softwares is it's just more streamlined, doesn't require an additional export of a file to get it ready to operate.
And then along with the streamlining, it actually has faster algorithms, right?
Yeah, the software actually calculates where to run the tools in a more advanced way now. So it'll keep the head unit down and travel to locations where it's removing metallization and not lift the head unit up multiple times if it doesn't need to. So yeah, the algorithms have improved as well.
That's awesome. And one more thing I wanted to talk about CircuitPro with you was the seat licenses. Talk about the upgraded seat licenses and who that really benefits.
So what's great is LPKF designed the CircuitPro software, and we have control over the license. So we're allowing multiple downloads of CircuitPro for all of our customers. When you purchase the software, you can download it up to 10 computers, which means that universities and small businesses that might have multiple research engineers can do their design prep, data prep away from the machine if it's in operation. They can play around with their design, get it ready, and then once the machine is available, once a project is off of it, they can just go open their file at the site with the machine, the computer with the system.
That's awesome. It furthers, along with the automation aspects of like the tool change, it further allows engineers and students to stay productive while waiting for the machine, while waiting for the PCB to be ready. Another feature introduced in 2011 was the upgradable system path. Now this is really cool, and I just wanted to point out on the screen you see the Protomat sizes. Those are actually metaphorical in nature. The Protomat S103 is actually the same size as the Protomat S43, but the features are obviously much more. So Rory, talk about the upgradable path and what that means for those who may have their applications change in the future.
Yeah, this is great. Previously, even on the last generation systems, if you bought a low-end unit with a 40,000 RPM spindle, you may be able to add the Fiducial camera and vacuum table, but that was it. You can't upgrade the motor. You can't add the tool change. Now we've created an upgrade path so that if you buy the S43 system, which you can add the Fiducial camera and vacuum table to, but if your projects get to the point where you want a 60,000 or 100,000 RPM spindle, maybe you start doing Rogers materials to Conic and get into the RF applications, you can actually upgrade the S43 on site with a kit. You would get a new head unit, turn it into a 60,000 or 100,000 RPM motor, and then you can add the tool change, and whatever features were included with the 63 or 103 would come standard in that kit. So you can go all the way from an S43 to an S103, and your machine can grow with your company and grow with your projects. And this is great because these systems have an average lifespan of 8 to 12 years, and you really may want to advance that system to a project that you didn't think you needed when you first bought the unit.
That's really cool. I really like that option because I'm stuck with my 92 Oldsmobile. I don't get to upgrade it. But if I get an S43, I can upgrade that. So I think that's really cool. Bringing things together now, we've talked about a ton of new features that have been introduced, from the auto tool change to the Fiducial recognition camera to the tool depth calibration to CircuitPro. So what does that all mean? What are the end results when you put everything together? Well, these improvements have generally made the machines faster, more accurate, and capable of processing a much wider variety of applications. We've talked about automation. We've talked about being more productive. We talked about gold materials and Rogers materials. They've done so much. And the amazing part of that is you may think, well, okay, now what's the hit going to be on our company's credit card? And what's amazing is the way we've been able to innovate and keep things equal. We'll get that into a minute, but I just wanted to talk about some of the overriding aspects. First, in milling resolution. Rory, in 1994, with a 91S, 92S, or 93S, you could mill at a resolution of 0.31 mil. Now, with the current Protomat S series, you're at a resolution of 0.02 mil, 2/100ths of a mil. Talk about what milling resolution actually means.
So the ability of the machine to travel the XY positioning and go to a location that's being instructed by the software and the tool path calculations that it's generated. Previously, the resolution at 0.31 mil, it's going to get you a circuit board, but the location and repeatability, and that all plays into your resolution. And what has advanced over the years is the stepper motors, the lead screws, the gantry. We've actually taken the weight of the head unit off the gantry, and all of those play into the ability to improve that to a 0.02 mil resolution. So extremely precise PCB milling with very accurate movements of the head unit and the position of the tool.
That's awesome. You know, I was just passing Stefan in the hallway. Stefan is our company president, for everyone who doesn't know. And I was talking to him about milling resolution because I had the same question. What does it really mean? And he said it's like milling in high definition. And I really liked that description of it. Along with milling resolution, one of the other overall improvements that has been made from 1994 till now is the travel speed. Now, in 1994, our machines operated at 40 millimeters a second. Today, they're at 150 millimeters a second. So that's over 3 times as fast. 150 millimeters a second is actually 360 inches a minute. That's a lot. Rory, let's say I want to make an average 3x3 board, double-sided. How long would that take me in 94, and how long would that take me now?
Well, in 1994, the machines would be traveling very slow, around 1.5 inches per second with 40 millimeters per second. So it's really traveling at a rate where it's taking a while to get the board done. And you would be looking at about an hour for it to do a basic 3-inch by 3-inch board. On the machines today, that same board, a double-sided board, may only take 10, 15 minutes per side. So you're looking at 20 to 30 minutes to do the same board. And that's on a rough comparison. It may even be faster because the algorithms, the travel speed, the tool change, all those improve the processing speed, and you don't have downtime while the engineer is waiting to change the tool position on some of the new machines as well.
Exactly. I'm glad you mentioned the automation because not only is it faster, but you can stay more productive because of the automated features. So I mentioned about price. Now, what's pretty amazing is that with all these improvements, with the improvements to the features and the improvements to the milling resolution and to the travel speed, prices have not improved that much. So in 1999, we introduced the Protomat C100, which debuted with a price of $21,900. Now, what's amazing is that the Protomat S103 is currently $25,218. So in terms of comparing features versus prices, you can see on the chart here that the features have jumped up while the price points have nearly remained the same. Rory, talk a little bit about this.
This again relates back to the research and development LPKF does to incorporate these features that have proven to help with projects, help with precision, help with the processing times, and incorporate those on machines at a same price point there the units were at before. So the C100, the S100, and then the new S103, the price doesn't go up very much, but we've added a great deal of features that save time and money with the applications.
Truly, truly remarkable to keep that at that same level while increasing the features. Now, to bring everything back together, I have this little chart here. You can see in 1994 with the Protomat 91S, 92S, and 93S, none of the features we talked about were standard or even available at that time. You can see in 95 We added a little more, 99, 2003, 2005, all the way to 2011. So now, Roy, let's say someone out there watching thinks, hey, this is great, you've added all these features, but I necessarily don't need all of them. Talk a little about what their options are.
Well, this is still going back to the upgrade path, and one of the benefits that the machines offer is we have machines that start out at around $8,000 for an entry-level E33 system. That one doesn't include any of the features that you'd see other than CircuitPro software and improved travel speeds and positioning. But when you go up to the next machine, we have optional features like the vacuum table and the Fiducial camera. And then the next step above that is the ability or the included features, which would be the Fiducial camera and the automatic tool change on the S63. So we've dialed it in for the best features for the machines, as well as the ability to upgrade features and help out with budgets, and the ability to get a machine that may not have the Fiducial camera and vacuum table, but you can add that if you need it for your applications when the budget becomes available.
Exactly. Or you can get our Protomat S103, which features all the features standard. So I think it's really great, and I'm glad you brought up the upgrade path again. Listen, I'm pretty wiped out from our journey, so I'm going to jump back in our DeLorean and hand things back over to Ashley to take us out.
All right. Thank you, Shane, and thank you, everyone, for tuning in to today's webinar. It's amazing how far in-house PCB prototyping and technology in general has come since the 1990s. I'd just like to ask everyone who viewed the webinar today a quick question. With all the features that we talked about, I just wanted to see which one did you find the most impressive? Was it A, the automatic tool change, B, the airfoot, C, the fiducial recognition camera, D, the vacuum table, or E, the automatic tool depth calibration, and finally F, maybe something else we talked about today? If you just want to take a moment and answer this question, we'd love to hear some feedback from all of you. All right, so it looks like most people decided that the calibration and fiducial camera was the most impressive new feature at 33% both. Next was automatic tool change, and finally the airfoot.
And Roy, talking about these poll results, what's pretty cool is the auto tool change, the fiducial camera, and the automatic tool depth calibration all work together, and we talked about that earlier, so that's pretty cool that I think everyone thought that was some of the most impressive.
Exactly. Those features have been incorporated because of the benefits, and they really do save a lot of time for the engineer. And so I could see it saves me a lot of time when I'm running the machines at trade shows and in the field. So, yeah, definitely some of the best features ever added to these systems.
Awesome.
Okay, once again, thank you for tuning into the webinar. We hope everyone found something of value. We'd like to take time now and answer anyone's questions. If you have a question about features, systems, or just even in-house prototyping, please don't hesitate to ask. So we'll give everyone about a minute or so to ask their questions now. Okay, it looks like our first question is from Bob. He's asking, the new Pro software, how far back on the various tables does it work? The LPKF 93S?
So the CircuitPro software is going to be backwards upgradable to the S63, or I'm sorry, the S62, the S100, and the S42. But beyond that, the CircuitPro is not going back to machines going back to the mid-90s and late 90s.
And then Rory, along with it, I think Bob also asked, what operating systems does CircuitPro? Does it work all the way up to Windows 8?
It's specified to work with Windows 7, Windows XP, but Windows 8, it's really not the latest format that it's been assigned to. So, but LPKF does work to make our software compatible with the latest Windows releases. So, it may be a free upgrade that we do with the software, or we'd recommend operating with Windows 7 or XP.
Okay, and it looks like Bob had one more question. Have you done anything about tool sharpening on site to reduce tool cost?
I have had customers that have done their own sharpening. With the depth ramp on the newest machines, that's something that will play into the depth of cut. It will pick up the tool and then drop it to that same point on the ramp. So If you have a sharpening method and it does work, that's something that could be used, but it's something where our software actually only uses the smallest tooling for isolation of the design and for only small gap widths. So the software actually picks up larger tools automatically and starts using that in the improved algorithms. It's something that was done before, but using the 100% carbide tools from LPKF, they do last a long time, and then the software algorithms minimizes the tool cost that you would have if you were to have a very detailed design, a high-density board, or a lot of small gaps.
Hey, Rory, there's a question coming in from Mitch. He wants to know about the X60. Now, the X60, as it appears, would not have been upgraded much, but talk a little bit about some of our larger working systems, including the second generation ProtoMat H100, and what options are available for those.
Yeah, well, it's great that he asked that about the X60 because, you know, you don't need to reinvent the wheel when the wheel is working, but the X60 being a very precise large platform system, it does have the ability to have the Fiducial camera added to that. So not only that, but we've reduced the cost of the Fiducial camera so that it can be added to the X60 model. I believe it's now $3,500 and allows you to do the alignment and precision work that you would want to do with an X60 system if you were to use a panel and need to do some reworking or reloading. Also, the X60, you know, we come out with new machines every few years, but it may be a couple years before the X60 sees an overhaul. But the H100 also has the ability to do large boards. So it looks like Mitch is looking like he needs the 24-inch work area, and that would be where you would want the X60 system, and then, again, having that Fiducial camera option. It's a very nice machine for those large boards.
Roy, another question from John, and maybe we should have mentioned this earlier. Talk about the difference. What is the difference between S43, S63, and S103? Essentially, what's in the name?
So the name of the S series, it actually plays into the spindle speed, and actually the way that the machines were named by LPKF, an S really stands for the work size. The S represents the 9-inch by 12-inch work platform, and then the number coincides with the spindle speed. So an S42 had a 42,000 RPM spindle. An S43, we wanted to keep the same lineage with the product name, but it has a 40,000 RPM spindle, still represented with the 4. The S63 has a 60,000. The S103 has a 100,000 variable spindle speed, and that's adjustable and has settings saved out in the software for all the various tools that we run. So that goes to the namesake of the machines.
Finally, one question we got from Smith was, talk about trade-in options for some of the older machines. Do we do trade-ins?
LPKF can do trade-ins for older units. It's on a case-by-case basis based on the demand. A lot of times we'll take in a machine that really doesn't have a place. It's quite old and it's going to need some work, and we may donate that to a local high school. We can even work with the company if they want to donate it and do a free maintenance and cleaning where they're going to get a trade-in offer to LPKF. We do a maintenance, or they just donate it to a high school of their choice. So really looking more for a focus to get the machines into high schools on a bigger scale.
Okay, and it looks like we have another question from John. Is there a way to keep tool information going for multiple users?
So this is a great question. John's actually familiar with our machines in the latest models. The software, CircuitPro, actually keeps track of the life of a tool, and we'll actually recommend to the customer to replace that when it's wearing down and if it's going to reach the end of its life while it's running a project. That software keeping track of that tool is keeping track of it until the user tells it that it's going to replace it. So you can put that tool away, and what we typically do here at LPKF is we share tools, and I know that can't always be the case, but if we're using a tool, we may keep that one tool on the right-hand side of the tool holder, meaning the plastic casing that the tools come in a pack of 10. So we always keep the one that was being used on the right side. Otherwise, if the tools maintain their positions in the tool change bar, it will just base its tool life on what's currently loaded. And then if you reload a tool that you've taken out and maybe you need a different tools for a certain application, it will base it on the old tool life even after you remove the tool. So it's a very good question that the software keeps track, but it's based on tool life, and you have to keep track of that one tool that was being used.
Okay, It looks like we have another question from Bob. He's wondering, are there any laser add-on options?
The PCB milling machines don't allow for a laser add-on. There's a lot of gantry power supply cooling that go into our protolaser systems. It's actually a different line that is very capable of doing applications with fired ceramics, Rogers material, Taconic, FR4, and the lasers are standalone, about 4.5 feet tall, with all the controllers and the galvo scanner and everything that goes into it. So no, there's nothing on the PCB milling machines that have a laser option.
Looks like we may have to have a different Then and Now webinar on our lasers.
Yeah, that should be coming up soon.
Okay, and then Bob was also wondering, does the new system detect a dual tool?
It doesn't, but when you're doing the tool software setup and you're doing that scratch test where the camera's looking at the cut width, if you're using a V-shaped tool and you can't achieve a 6 mil cut, even after it's recommended an offset and reset the tool position, that tool may have been worn down at that 6 mil cut width or the 8 mil cut width and no longer be able to create that isolation gap. So that lends into the software keeping track of the tool life. And our software is pretty conservative as far as that tool life. So when it tells you that you've reached the end of it, you're most likely not be able to get an 8 mil tool, or 8 mil cut. But you would be able to save that tool and use it as a 10 mil cut or a 12 mil cut. So it doesn't detect that the tool is dull, but our software is there to give you advice on when we expect it to dull based on 1/2 ounce copper. And you can actually change settings or create your own tool list if you were always working on 1 or 2 ounce copper, and save settings that you find that it wears out if it is faster than what we've saved in the software already.
And I just wanted to add for everyone who's asking, this is Shane again, we'll send out a copy of this recording of the presentation and the slides, as well as the paper Then and Now that the webinar is based off of. We'll be sending this out to you all tomorrow. So Ashley, is that it for questions?
It looks like that's all the questions. If you think of anything later on, feel free to email Shane or Rory, and they can give you a call or email you directly answering those questions. Once again, thank you for tuning in today, and we hope you have a great rest of your Tuesday.
Thanks, everyone.